Alright, geometry class, this is Mr. Kim. This is a repeat of today's lesson 15.1, the mid-segment theorem proof. This is part 1. The next video will be part 2. Part 1 is algebraically proving that that the mid-segment is half the length, is parallel to the third side. So the mid-segment MN is going to be parallel to the third side AC. Okay, so I'm going to start from the beginning. We're going to get some coordinates for M and get some coordinates for N based on the fact that we have three pairs of coordinates here. A, what do you call it? A, H, B, K, C, L. So to find the coordinates for coordinate M, okay, M is going to be the midpoint of AB. So we're just going to do the midpoint formula, average out your X's and Y's. So that will be A plus B divided by 2. And then now the y coordinates will be your k up here and then your h over here. So h plus k divided by 2. So that's a midpoint for M. Same thing for N. We're going to take a coordinate B and C and get the midpoint for N. So B plus C divided by 2 would be the average of the x coordinates, and k plus L divided by 2 is the average for the y coordinates. And the reason we went B to C and then K to L is because coordinate B and coordinate C, vertex B and vertex C are is the alphabetical order. Now from here it gets a little tricky. What we have to do is prove that the slopes are parallel. So what I'm going to do is using the slope of AC and the slope of MN, if I can simplify MN, because it's going to be quite funky because of all these denominator 2's, if I can get MN to equal the same slope as AC, then we've got ourselves some parallel lines. So let's make that happen. So first, let's find the slope of AC. I'm going to do that underneath the triangle because that's super easy. So step 1, finding the slope is just y2 minus y1, x2 minus x1. So I'm going to pull my y2's and my x2's from here, my x1's and y1's from here. So that'll be L minus h over C minus A. And this is going to be the slope for line segment AC, or segment AC. Now to find the slope for MN, it's a longer process. So we're going to start over here. So the slope of segment MN is going to be the same concept. I'm going to use N as my y2, y1, and M as my y1, x1. So y2, let's take that back. Y2, x2, y1, x1. Okay. So k plus L over 2 minus h plus k over 2. Remember what I said in class, we need to put a parentheses around h plus k because we're subtracting the entire quantity of h plus k over 2, and that's going to be my delta y, my delta x, or my change in x is going to be b plus c over 2, subtracted by the a plus b over 2. Again, parentheses here. So this represents my slope so far. Now, they don't look anything alike at all yet, but they will soon. I'm going to have to simplify this, simplify all of this so that it can become L minus H over C minus A. So let's just work this to the side real quick. I'm going to distribute this negative into the H plus the K. So it'll be K plus L minus H plus K all over 2. If you're wondering how I did that, since they both share a denominator of 2, I can just combine the numerators or write the numerators in one line since the denominators are identical. And all over, and I'm going to do the same thing right here, distribute the negative on the A plus B, B plus C, minus A minus B. Wait, I forgot something. That plus should be a minus, so let me erase that. There we go. Where was I? B plus C minus A minus B. Okay, that's good. All over 2. Let's simplify the numerator. So these k's will disappear, right? Negative k, positive k. So I get L minus H over 2 all over B minus A over 2. Now what I'm going to do is remember that this fraction bar right here is really a division sign. So I can then take this, we call a rational expression, and Let's write it side by side so it makes it easier to divide. So that's what I'm going to do right over here. So L minus H over 2 divided by B minus A over 2. Multiply the reciprocal when we multiply or divide fractions. So L minus H over 2 times 2 over B minus A. Cancel out the 2's, so our final answer, or our final slope for the segment MN is B minus A equals the slope of segment MN, which is identical to the slope of AC. So now we can say that AC is parallel to MN. If you need more, watch the video again, and the next video is going to show the proof of the sides, the mid-segment being half the side length of the third side. So the mid-segment MN being 1/2 the length of AC. Alright, watch the next video.